solving this question, and the question says a charge of uniform volume density of 40 nanocoulomb per meter square fills a cube with 8.0 cm edges. Then we're asked to calculate the flux through the cube. Imagine this is a cube, and if I have a cube like this, with a test charge inside, and we're given that the volume charge density is this, and we need to determine the flux. Since we know that this is a cube and each length is 8 cm, this is 8 cm, then for us to find flux, we use Gauss's law. And the Gauss's law, we have that the flux is equal to Q divided by epsilon naught. But the problem is that we don't know what the charge inside this cube is. We don't know if it's positive, we don't know if it's negative, we don't know if the value of the charge itself. So for us to find this, the charge itself, we're already given that a hint, we're given a hint that the volume charge density is this. So that means the rho is equal to Q divided by V, and this implies that Q is equal to rho V. And we're given the volume charge density to be rho is equal to 40 nanocoulomb per meter cube, which is equal to 40 times 10 power minus 9 C per meter cube. And we have that the length of this cube is 8 cm. So we have that the volume should be equal to the cube. And this is equal to, when you convert this to meters, we have 0.08 cube, and this will be equal to 0.000512 meter cube. So with this, it will be easier for us to find what the charge is, and then plug in the value of the charge, then we can find the flux. So for us to find the charge, we have that this is Q is equal to rho V, and this is 40 multiplied by 10 to the power minus 9 multiplied by, let's convert this to standard form as well, which is 5.12 times 10 to the power minus 4. And this is equal to 40 multiplied by 5.12 times 10 to the power minus 9 and minus 4. And this is equal to 40 by 5 is around 204.8. 40 by 5.12 is this. Then times 10 to the power, this is minus 13. So we can decide to reduce further, which is 2.048 multiplied by 10 to the power minus 11 coulomb. So this is the charge. This is the charge inside this box. So now let's find the flux. To calculate the flux, we're going to use this formula. we will use this formula, and if we have this flux to be equal to Q divided by epsilon naught, and Q is the charge which we've calculated already. That is 2.048 times 10 to the power minus 9 minus 11 divided by the epsilon naught is permittivity of a free space, is a constant, and that is 8.85 times 10 to the power minus 12. So let's do the simple mathematics here. This is 2.048 divided by 8.85 multiplied by 10 to the power minus 11 plus 12. And this is equal to, when we divide this, we'll be having 0.2314. Then multiply by, this is 10 to the power minus 11 plus 12 is 1. And we can decide to simplify it further by having this to be 2.314 Newton meter square per coulomb. So this is the flux. And if we decide to go back to the original question, then we can say that what we got is 2.314, and we can comfortably say that this option is the right answer. Thank you for watching this video. If you have any question, feel free to email us at lesalifacademy@gmail.com.